Hi, in this video we're going to factorise maybe, for example, a quartic. A quartic is when we have an x to the 4 term, or it might be even higher power, but it kind of looks a bit quadratic-y because like a quadratic expression might be something like x squared plus 16x plus 64. Now, is there a way we can use our knowledge how we factorise quadratics to factorise this more complicated expression, this quartic in this case, that we have here? So let's just imagine that we did have as a simpler question. We had just x squared plus 16x plus 64. And that'd be that's a traditional quadratic. We've got an x squared term, an x term, and a constant term. How would we factorise that? Well, we just find two numbers that add to give the 16 times to give the 64. And what are those two numbers? Well, it's just 8 and 8, isn't it? So we can write this as x plus 8, x plus 8. Now, using that, could we work out what the factorisation of this is? Because if we open up our two brackets, we're probably going to have the same numbers as we have here. So we're going to have the plus 8 and the plus 8. But what could we put here and here which would make it work? Well, here we had the x times the x gave the x squared. What times something would give the x to the 4? Well, maybe we should try x squared and x squared, because then the x squared times the x squared in the expansion would be x to the 4. But we also get 8x squared plus another 8x squared is a 16x squared. So it works. So this is the correct answer. But another way we could do it, if you don't like just kind of like putting the brackets there and using this kind of slight intelligent guessing type method, is to do a substitution. So what we could do is we could say, well, let y be equal to x squared. And the reason is because this expression here could be written as x squared squared plus 16x squared plus 64. And the reason is just laws of indices, x squared squared, you've got a power to a power, 2 times 2 is 4, so that simplifies x to the 4. But what's nice about this is that this expression is now in terms of x squared. We've got the x squared here, the x squared here. So if we let y equal to x squared, we have then y squared plus 16y plus 64. And then we can factorise that in the usual way. So that'd be y plus 8, just we have on the right in the blue. And then at the end, because we had this substitution of y is x squared, we can replace the y back for x squared. So we then have x squared plus 8, x squared plus 8, like that. So we have these brackets we have at the top. But I prefer to sort of think about like how is for factorising it's a normal quadratic and then appropriately modify these x terms to make it work, basically. If you had something similar, let's just say you had x to the 6 plus 8x cubed minus 9. If we use this kind of like intelligent factorisation method, if we think about this as a quadratic, and by the way, the reason I can spot that it's kind of quadratic-like is because this index here is double this index here. The 6 is double the 3. Just like in this quadratic here, this index of 2 is double this index of 1. Then if we just factorise as a normal quadratic, let's think about the numbers. What numbers add to give plus 8 and times to give minus 9? Well, it's 9 and minus 1, isn't it? So I'm going to put as the numbers plus 9 and minus 1. But then I've got to make sure that these two terms here multiply to give x to the 6. Well, it's going to be x cubed and x cubed, because x cubed times x cubed is x to the 6 by laws of indices. And that also makes this middle term work as well, because you can have 9x cubed minus 1x cubed is 8 lots of x cubed. So that's going to work again.